Good morning, everyone. Welcome to this seminar on Internet of Things. So, myself, Nivin, I am from Pantech eLearning. So, I'll be conducting the session here, this 1 hour session today. So, we'll just talk about Internet and Internet of Things in general, and we'll see some specific examples of IoT today how Internet of Things is used here. So there are like so many places that we can every day we actually hear about new things on Internet of Things. We might not even know that it is a part of Internet of Things. So we might see it as like an automation technology, but to automate anything these days, it need to be connected. So that is a very important part that IoT, you know, IoT plays in automation. So that two things to get connected, and it is not just automation. If it is just standalone, it might not be that safe to have a standalone system. It will work on its own without any help because in case of any technical issues, any problems, people should be able to that should be relayed to concerned people. So that type of things, are like very much needed when it comes to era of automation, industry 4.0, in all those cases. So the Internet of Things has a big role to play there. So we'll see. So in today's session, first we'll start with the history. I'm not going to going with the advanced. We are not going with the advanced practical implementation of Internet of Things. We'll just see the history of Internet and how it evolved, and then after that, how Internet of Things evolved. What is the need of Internet of Things? We'll go through all that, and we'll see. We'll just get familiarized with the term Internet of Things. So Internet revolution. So first, before talking about Internet of Things, we have to talk about Internet itself. What is Internet and its history? So Internet can be divided into these five eras. So these eras are like different milestones in development of Internet. And the last one you can see is Internet of Things. So the first one is Internet of Boffins. So Internet was originally created in 1969. So it was in a inclusive network. It was exclusive for only for selected number of institutions. So it was originally made by Defense Department, U.S. Defense Department, and it was called ARPANET. So it was called ARPANET, and it was a network to interconnect all the different defense institutions, all the different defense base. So it was a very secure and exclusive network. Only certain people can access that. So that it was made by U.S. Defense Department. So the prime objective of that network was to interconnect all the research institutes. So if you take any country, any well-established country, they'll have take India itself. We can take India itself. Like in case of research, any major leading research, the biggest investor is the government. So government means in the sense like it could be the Defense Department or some other department of government. So in our case, if you take like technologies like defense or medicine or space science, that in all those cases, the biggest investor in India itself, biggest investor is the government. Government provides money for all these different researchers, and they develop different type of weapon systems, different type of space exploration systems, and medical systems, different type of in vaccine developments and other type of medical uh, medicines are developed using the same kind of research umbrella. So that same as that in US, it's the same thing. So that means under defense department, there are so many researches going on at the same time. So this research is not going on in some some military base. It is actually happening in civilian institutions like universities. Like we can say like Ivy League schools in America, like Stanford or Caltech or MIT, so Harvard. So these type of high-end educational institutions, they're not just education in institution. They have faculty that are like uh, high-level scientists. Faculty that are high-level scientists. They'll teach classes, but their main work is doing research on some subject. So that will be always funded by the government, because government need to monitor it 100%, because it might be a technology like that. So if it is in hands of a private person, they cannot have that type of control. So they need to invest fully in that, and they need to have full control, and they need to monitor it 100%. So that is the purpose of all these. So that in every one of these Ivy League schools, they'll have their own research programs running. So the initial objective of internet or ARPANET was to interconnect all these institutes to make the research work more efficient. So like, for example, two institutions, they are like far apart, like 1,000 kilometers or 2,000 kilometers apart. And they are doing research on similar subject, similar things, so similar technology. So the two teams, and they can share, they can share their findings each other in real time. So that will make the research more efficient. So you don't have to wait for like 1 week, or you don't have to wait for like a mail to receive. So you can, or you don't have to uh, rely on these other low level technologies like radio and things like that, or telephone. It is not very efficient compared to a real-time communication. Real-time communication means you can just type something in, or you can share documents in real time. They can see it right there at that time. So that was the original purpose of internet. It was made to interconnect all these institutions, so they can efficiently uh, do their research work. That's why the name Internet of Boffins. Boffins, the term means, it is like a slang term for academic researcher, mainly like in general, like an academic person. That is Boffins. That is a Boffin. That's why it's called the Internet of Boffins. It wasn't available to civilians, and any civilian who had access to that network was a researcher. So then only military personnel and government people can access the network. Then after, even like in early 1990s, like 1990s, 89, 1990, they started giving access to other people. Still, the network is only used for the single purpose, for sharing papers and journals and things like that, findings. So they can easily, search for something they need. They have some doubt on some result they have, and they need to see if someone else have done done similar kind of experiments, and what are the results they got, and they can compare it, and they can find they can find an easier way, something like that, like the same way we use internet today. But it was very limited to this single purpose. So even when they made it open to some people, it was only useful to these academic people. So more people can pay money, and they can access it. So that's how they started making it more open. And in 1995, they made it completely open, so any small network can connect to any local area network can connect to the switch, and they can access the internet, connect to a broader, like a bigger switch, and they can connect to the internet. So that was when internet was made public. So still it was called, the era was called Internet of Geeks. So geeks is a term for a slang term for like people enthusiast, people who are interested in technology, science, and all that. So people who will spend most of their time uh, on these, like technology buffs. So people like that. So they are like, they're called geeks. It's like a term that is used to refer to them. So Internet of Geeks means that internet at that time, it wasn't that useful. Right now, internet is everything. We cannot live without it. We need it like every day. We have to use it for everything, like communication or getting information for different purposes for our job. Yeah, everything depend on internet. So, but back in 1995, that wasn't the case. It wasn't that useful to most people because there wasn't that many companies or that many applications, web applications available at that time. It was just simple things. You can just email or chat rooms, things like that. So these are not that much, attractive to normal people. They don't have to go to the trouble. It is very expensive to set up the thing because computers were very expensive back in 90s. So electronic parts was in this, uh, this inexpensive. Back then it was expensive. Computers itself was expensive. Then to set up a internet connection, you have to spend more money. And still the connection was very slow. Your computer itself can only have like a MB size memory. So MB size memory, and so you can only have like KB less, level of internet connection. So it was very slow, and so only like certain people who are like enthusiasts, who are interested in technology and all these things, they were only interested in internet. They were connecting to it, and they were like experimenting with it. That was the like beginning of internet. It wasn't like an exactly like a uh, industrial platform at that time. It was just for people having fun. That's it. Internet of Geeks. That's why it's called Internet of Geeks. Only like so. Then like as a result of this, of course, like big companies like right now, uh, like if we take Amazon itself, Jeff Bezos, he was also a geek. So he also knew about the this whole thing, the internet and how it connects people. So he was the one of the earliest people to make use of that. So he started Amazon in 1996. So it was started as a like a online library, like library, not like library, a bookstore, online bookstore where you can just go to his website and you can browse for different books. So that is very useful compared to what was available at that time. You have to order, it is like, even if you have a system where you can call someone and get a book or order something, still you have to go through, yeah, if you don't know if whether the book is available or not, you have to call someone and you have to see. And if you're just looking for something you want to read, then you have to decide first of all what you want to read. So if you have so many titles and so many different genres and things like that, you can easily pick a book from that. So if you don't have any ideas, that it will make it much more harder. Then you have to just go with something you'll get. So, but with the system like this, online bookstore, that means you can go through it and you can easily find what you need, and you can order it within like matter of days. You will get it. It'll be delivered to your doorstep. So that was the original Amazon, and then he expanded it to retail, and now it is like they're not even, their leading business is not even retail. online retail. It is a cloud business. They have like data of almost all, almost all the big tech companies like Google itself. So then, so that was like the era. Like even at that time, this more people were starting to see how how revolutionary this was. Like computers were useful back then only for certain people. Like it was also the era of boffins for computers, because only like professionals were using computers. Like it was not useful to normal people. So then as the advent of internet and the next era, the internet of masses. We all know about the we all know the term IT boom. So Bangalore, the city like Bangalore, or the in America, San Francisco or California, the state itself is California is like one of the richest states in the world. Like its GDP is much more than like so many other countries, like not just small countries, like big countries. Like it is like if you take the GDP of California and compare it with the Britain, Britain's GDP is like a little bit more than GDP of California. It's a very rich state because state in America because of the IT boom and all these tech companies. Not IT, not just IT boom. Even before that, it was the like technologies. All things were like mainly focused in that one city. And then after IT boom, so many companies started, so many new startups, so many new IT companies, internet companies started, and so so that same thing happened in India. So it happened in Bangalore. So now Bangalore is like San Francisco of India. So so the IT boom that happened because people were aware, people suddenly became aware of the usefulness of internet, how we can use it, how it is easy to do business using in internet. It is easy to reach people, and for advertisement, everything is much more easier than any conventional method that we use. So in a consumer world, that is very important to the businessman. So that idea actually, that exposure actually gave rise to this internet of masses, this new era of internet of masses. So internet of masses means internet became popular, and internet became an everyday thing during this era of internet of masses. Still, everybody wasn't able to access it because still computers were expensive, and even in 2000, the internet connections, it was very slow, and you can have like dial-up connections. It would be very slow, and also still you have to pay so much money for that. But then afterwards, like cables were, cable internet was there, but still it was very expensive, and most people couldn't afford that. So that's why you can say it is the era of internet cafes. So if you live through that time, you can remember the era of cafes. So like you can whatever you want to do, like if you want to make a application, application for something like an exam application or a job application, or like different type of government results, whether it is like PSC or whatever, uh, all these things will be um, all these for all these things we can make use of internet even at that time. So people had to use internet, but they couldn't afford it at their home, so they have to, even if they can afford it, they cannot afford a like high speed internet system. That's the advantage of cafes, internet cafes. So they can have like they can have multiple systems, 10 or 15 systems, and they can have a very high speed internet connection there, and people can pay some money and they can browse, they can use they can download things, and they can do whatever they want. They can watch YouTube videos or download movies, whatever it is, and they can make use of it, they only have to pay a little amount, like 20 rupees or 15 rupees for an hour, like that. So that was the era of internet of masses, and internet cafes. So internet became popular after that. And then in 2000, after 2007, mobile internet. That was another revolution in case of internet. Like number of devices and number of people able to access the internet increased so much beyond 2007, because of mobile internet, because it became more accessible to everybody. Like you all you need to do is you need to have a handset, a small, like you can use a Nokia handset, and you can connect to internet, connect the internet. You don't need a separate internet provider. You can internet service provider. You can use your own mobile SIM card, and through the SIM card, GPRS or whatever, 2G or whatever you're using, you can get internet. It wasn't exactly like the smartphones we have today, but it was useful in the sense you can use like basic things like Google. You can search for different things, and you can use Facebook, or you can check emails, and so that type of basic things can be done using in the mo internet mobile phones at that time. So that was a tipping point where the internet became more popular in the sense more people were able to access it everywhere. They don't have to go to a specific place. Still, if you don't have a system, you have to go to an internet cafe, because there are so many things. You can only do a limited number of things using your phone. But basic things like you can watch, you can use like YouTube, that type of things you can do do using these phones. Not maybe earliest phones, like after that, like Symbian, like Symbian based OS, like Nokia phones. Those phones were able to use. We can stream YouTube and all those things, like so in those phones. Then beyond that, like smartphones, what we have right now, they are capable of doing so much more. Then the era of Internet of Things. So era of Internet of Things is a result of automation, automation and Industry 4.0. The industries became more and more automated, not just industries, everything that we use, like the simple appliances that we use in our home, everything became more smart and automated. So because of this, the device or the whatever equipment it is, it doesn't need a human to like connect with the other devices, or connect with the storage, like data storage or something like that. It can make its own decisions, and it can do some it can do something based on that decision. So this was made possible because of automation. So because of that, these things need to be connected to a network, so they can easily interact with the world of internet, like whatever application it is used for. So that automation made this possible, and automation was made more liberal, more easier, like beyond 2012. Things like if you take robotics itself, like making a smart robot like in like 10 years ago or 12 years ago was very it can only be done by people who have that kind of resources, like a robot that can self-navigate, a robot that can or a robot that can robot manipulator, a 3-degree freedom robot manipulator, that or 9DOF or 9DOF robot manipulator that can move around in 360 degrees in space, and it can pick different things. We can attach a camera, and the camera, it could be a 3D, it could be a depth camera, or it could be a stereo camera. Using that, it will detect the object in space. So it's not going to detect the object in a plane. It is going to detect the object in a space, and in space, and it can move, the arm can on its own move to that position and pick that object. So that is like 10 years ago, 12 years ago, that took someone like a person, an independent person on his own, on their own. If they try to do that, that might not be even possible. They have to spend so much time on that. But right now, it has become more liberal, much more liberal. Like you can make your own automated. So that is like robotic example in automation case. You can make like that type of automatic robots. So things like frameworks like ROS, robot operating system, you can use that to make it automated. And other type of software automations, different type of APIs, and REST APIs and React and all those things. How we can use these in automation, web automation, how people are able to still they can make their own application. You can make your own application. It is everything is available. So many open source things are available, and so many tutorials and books on these things are available. You can watch videos and things like that. You can learn yourself. Yeah, so there is no like that gap between industry, something that was kept from no like civilians, normal people. That boundary that 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 is actually getting dissolved more and more and more. So we can do whatever industrial in industries, the products are much more tested and much more refined, but we can make our own custom applications of the same thing. That type of resources are available. So automation is that is a liberalization of so these information, all this information. So that is made because use made that was made possible only because of internet. So that made that give rise to the era of Internet of Things, more devices connected. So why internet? Why do we use internet in the Internet of Things? Like anytime. So like obvious things, anytime, anywhere, any person, any business, any device, any network. So anywhere is like still not 100% possibility. We won't be able to get internet in so many places on Earth. So, but still wherever you are getting the connection, you can do all these things. Then what is internet? Like a definition of internet? No one owns it, so there is no ownership. Like there is no one single ownership person or entity or organization that owns it. It has no formal management organization. It was originally developed by the Department of Defense, US Department of Defense. This lack of centralization made it less vulnerable to wartime or terrorist attacks. So if it is centralized, it is easy to, if it is a centralized system, it is not possible to make a centralized internet. The idea of internet itself is a decentralized network that is spread around the world. That is a collection of small networks, and so that is a basic idea. That is a basic idea of internet itself. So it is not possible to make it centralized. So if it was centralized in any ways, then it will be, because centralized means you only have to attack a single place, then you can take down the whole internet. So that is not possible right now. So then to access the internet, and existing network need to pay a small registration fee and agree to a certain standards based on TCP/IP transmission protocols. So then you have to this is like the procedure to, if you want to add an existing network to the internet. In the history, then when we go into Internet of Things, so the term in Internet of Things was first coined by Kevin Ashton in 1999. So what is Internet of Things? So Internet of Things is a network of physical objects, devices, vehicles, buildings, and other items embedded with electronics, software, sensors, and network connectivity that enables these objects to collect and exchange data. So it's the same thing that we have been talking about. Like I didn't like say it in like one paragraph, but the same thing that we've been discussing the whole time. Like it is like a collection of object objects in the sense it could be devices like appliances or a car, like vehicles, any kind of vehicles, or buildings, could be as buildings, or collection of objects, things. So and other items embedded with electronics. So they itself a building or a car. A car is a mechanical. So if it is a IC engine based car, it's a mechanical car. Then it is a mechanical device, mechanical machine. So for that device to that machine to connect to internet, it needs some electronics, hardware embedded with it. So using that electronic hardware, it can connect to the internet. So then electronics. So to run the electronics, of course, we need software. So software can be like it can be a actual software, can be like user software with the user application with the UI and all that, or it could be just a simple, C program, a C code or C++ code that is just running in a super loop. It could be a real-time operating system. So it could be software, could be any of these things when it comes to Internet of Things. Then sensors and network connectivity. So then the last thing is sensors. So sensors means like it depends on the kind of application, kind of device that you use. Any device is going to need sensors. Like if you take a simple appliance like an air conditioner, is going to need a number of temperature sensors to regulate the environment on its own, like regulate the temperature environment on its own. So the sensors and network connectivity that enables these objects to collect and exchange data. So that is basically, that is internet. Like whatever we do in internet, it is just simply collecting and exchanging data. So whether we are sending emails or whether we are browsing, using Google or watching reels in Insta, whatever we're doing, it is just a collection, exchange. You send some data or you send some commands and you will get some data. Mostly a user only sends commands and will get some data. So that's the basic. That's one way in which you can basically uh, define internet. So this is like a definition of Internet of Things. So we can have like so many different definitions. So this is one of the definitions. So then anytime, anywhere, machine to machine communication. So this is like another good point here, machine to machine communication without any humans. So like examples of Internet of Things, you can implement it on your campus. This is one example of Internet of Things, how we can utilize Internet of Things. You can implement that in campus, and different examples are here. Smart Internet of Things in school, and personalized learning, adaptive e-textbooks, digital classrooms, and whiteboards and displays. So like you can have like so many different, like whiteboard these days is just you can just manually write, whether even if it is like some digital thing. Still, if it is not connected to internet, if it is not smart, then you can just write manually and it will show that whatever you write. But you can make it much more smart by connecting it to the internet, and like predicting, like auto, like right now you in our phone we have dictionary settings in our keypad. So whenever we type, it will auto correct and it will predict the next word. So that type of things can be implemented with the whiteboards, with if you have Internet of Things. If you have a whiteboard that is capable of doing that with with the Internet of Things. And like if you write some formula, then it can automatically just detect the formula and it can point that this formula means this. It can like show a hypertext to a link. So if you press on that link, then it will just show whatever details in that link. So that type of things can be done using Internet of Things with a simple application like whiteboards. Then iBeacons. So iBeacons like for localization, for identifying where you are and where is navigation and all those type of things. in a campus. So this is all these examples is like a school campus. In school campus, how we can implement Internet of Things. Then video recorders for lecture capture, automatic video, automated video like recording, and then upload that to a cloud or drive, so you can online drive, so you can access it. The students can access it whenever they want. Then international collaboration and social exchange programs. So you don't have to directly go to normally social exchange programs means you have to, the person will go from, a student will go from one institute in one country to another country, and one student from there will come to this country, and they'll exchange of students, and they'll study there 1 year here. That student will study there 1 year there. That is normally how social exchange programs work. But you can have it. You can have a social exchange program with a virtual social exchange program. So these days that is not even a thing. We can like have like a class of people, like people in class in India can study with people in you know people in Europe, some European country, or in some country in Africa, or some country in America. They can connect to connect to that, and connect to that other classroom, and they can all have same class. So online testing, sensors and trash receptacles, then robot cleaning devices, student and device and e-textbooks, notebooks, tablets, file and program storage, local or cloud-based, demographic, academics, academic behavior, LMS, CMS, SIS, educational programs and other things, video files, lectures and all that, network application analytics, monitoring devices, and network behavior, surveillance and security cameras. So you can have like smart surveillance systems, uh, augmented and virtual reality based classrooms. Uh, Then complete coverage with high performance Wi-Fi, wearable for athletics and attendance tracking. So athletics, so we already have like so many devices, like health fitness devices, like smart watches. So that type of similar devices can be designed specifically for athletes to monitor their performance every day, and and also attendance tracking. So people can have like a tag or some type of watch or something like that. They don't have to like register attendance. They don't have to go to the staff and or the staff doesn't have to take attendance every day. They can just walk into a classroom, and automatically attendance will be registered, because you can have an NFC based uh, device. So that means as you enter, automatically your device ID will be registered at the receiver. So that device ID means you'll have your name and what class you, what time, and all that will be registered. So there is no need to, or there is no mistakes can be made there. So then we can make it like, in that case you might say like, what if friend of the person, they take that device to the class, then it will be like they are attending the class. But we can make it more secure, like only if that person wears, it'll like, we have like so many ways in which we can detect the person. Even if you're wearing it on your wrist or somewhere else, you can detect it like so many different ways, like to identify the person. So you can use one of those mechanisms and identify the person, like not fingerprint, exactly fingerprint, like fingerprint, some other system. Supplies in inventory tracking by sensor, auto reorder, and maker spaces with the 3D printers and laser trimmers. Internet of Things based HVAC. So HVAC means heat, ventilation, air, cooling and cooling systems. So that is that can be automated. So for that, why we need internet, because we can use like weather predictions. Based on the weather prediction and also the current data, the things can the whole ventilation and air cooling, heat and ventilation air cooling system can work much more um, efficiently. It will consume less power because of that. Monitor and display of air quality throughout the school. Sensors tracks bus, verify the student passengers. So this is a very good, useful system for parents if they have a small child going to school, uh, like kindergarten or first standard, like that. The parents doesn't have to go directly to the school and pick up the child. They can easily track the child, track track their children using some kind of tracking device like this. So once the student enters the classroom, they'll be notified. Once the student leave the classroom, they'll be notified. Once the student enters a school bus, they'll be notified, and they can they can see where the school bus is in live, and they can pick up their child from the drop point. So that is a very efficient and safety system that is very useful, practical and useful system. Sensors in parking and IoT, parking lot and driveways. So these are like some of the applications. Then we can move on to the next slide. So this is like connected devices. How many connected devices are here? So we can see a chart here, chart representation. So this is only up to 2020. So I only have up to 2020. So this is just so this is not to by heart the numbers here. We just want to see that revolution, that how much. So this ratio here, you can see a ratio, this number here. So this is 0.08 and 1.84. And the gap, you can see it's 7 years gap, 2003 to 2006. So this ratio is the ratio between number of world population and number of devices, connected devices, devices connected to internet. So 500 by 6.3, that is the ratio, that is this ratio. So 500 billion, so 500 billion means 0.5, so 500 million means 0.5 billion. So 0.5 billion divided by 6.3 billion. So it's 6.3 billion. So we'll get this ratio here, 0.08. 0.08. So that is like this ratio means connected devices per person. For a single person, this many devices, 0. Not even like one, not even like half, not even, even less than that, not even like 0.1 devices connected per person in 2003. But just in 7 years, you can see the increase. So at this point, there is more connected devices than people, like in the middle, like in 2005 or 6. Like 2007 or 5 or 7. Then in 2010, you can see 1.84. It's almost double. Like there is double the number of devices connected to internet compared to the world population. So 1.84. Then in 5 years, you can see that the ratio increased to 3.47. 7.2 billion people. Population is increasing gradually, not very gradual, but still compared to the number of devices, it's still very gradual. You can see it's 500 million to 12.5 billion in just 7 years. So 0.5 billion to 12.5 billion in just 7 years, and double that, exactly double that in just 5 years, and then again in 5 years double that. So still the population is more. So here you can see the ratios here, 3.47, 6.58. So in 2020, per person, almost 7 devices are connected to the internet. Almost 7 devices are connected to the internet. So that means how can a single person, even if they have a laptop and a smartphone, or like number of smartphones or number of like a tab, whatever it is, they cannot have like 7 devices. A single person having seven devices means that they might be some person who's making tech reviews. So that's only reason to have like 7. That's only excuse to have 7 devices. Otherwise, you have a problem. So the 6.58 means that if you compare it with population, it is not possible for all people to use. It is not possible for all people to use the devices connected to internet. And also we know that there are like so many people. If you take 7.6 billion population, there are like see if you take countries like North Korea or Cuba, they still don't have the kind of internet. They don't have internet at all like we have. It is a very closed system. So there are like so many places on earth still they don't even have electricity. So this type of 7.6 billion and 50 billion comparison is not useful when we consider all those factors. So 6.58 means almost 7 devices. So this chart is just showing what I'm trying to say here is chart is just showing how much important it is like Internet of Things, automation, how much it is useful, and how like this gave rise to this era of like this many connected devices per person. Life cycle for different IoT, and IoT always stays on top. Internet of Things, where whatever it is, whenever it is like it stays on top. Then it is like layer representation of Internet of Things. Like on top layer, there is people and process, like applications that we use, all those things like that. Mm. Then data analysis, like reporting, data mining, machine learning, all those things comes under data analysis. Data ingestion, like personalized ad, all those things comes under data ingestion. So first you analyze the person's data based on their Google search or search history or whatever it is. These days they're even using your audio. They can even listen to your audio, and based on that they can give you recommendations. I'm not exactly sure, but I think that they're doing that type of things these days. Uh, so that data ingestion means like giving you that personalized ad. So global infrastructure, like cloud infrastructure, like different type of cloud platforms, connectivity, communication protocols, and all those things comes under. Then at last, things, devices. So then things in home and all the how things communicate, sensors. So sensors, a sensor is a device that measures a physical quantity. So it is a device that can measure a physical quantity and convert it into an electrical signal, like a temperature sensor, for example, like if you take one of the most basic temperature sensors, like a LM35, it can uh, LM35, it basically it's like it uses the property of semiconductor material. That semiconductor materials are like silicon are susceptible to temperature, external temperature. It will change. So that is the basic idea. The idea of semiconductor itself is it can vary its conductivity. So in most devices, in most materials, the conductivity is a fixed thing. Either it is insulator or it is a conductor. But with the semiconductor, it can act as both, depending on the type of condition, external condition. So temperature is one of the factors that can affect the conductivity. So that mechanism is used for measuring temperature in that basic temperature sensor. So that mechanism is used, and based on the external temperature, the current flowing through the sensor will increase or decrease. Based on that, we can measure the temperature. So different type of sensors, LDR, water level sensor, discrete, two types of sensors are digital sensors and analog sensors. So then discrete classified into two. Any sensor that can go from 0 to 1 or 1 to 0. And different type of single board computers and microcontrollers. So you can use like 32-bit microcontrollers like ARM microcontrollers, or you can use an open source platform like Arduino. Arduino is very useful because you don't need to learn so much about embedded system to program using Arduino. You can just easily start it. A school student can easily make projects based on Arduino. It's very popular and liberal type of environment. If it come into like if you want to work in more in embedded system and IoT and all that, then you have to learn about 32-bit microcontrollers like ARM-based microcontrollers like STM microcontrollers or NXP, or you can Renaissance, Renesas. So this type of different platforms. You have to learn about that, and if you're going into multimedia and Internet of Things and all that, you need to study about these, or you need to study about single board computers. This is a Raspberry Pi. This is not used in industries, but this is a gateway to world of single board computers and embedded Linux. You can learn embedded Linux. You can buy one of these small computers and you can learn about embedded Linux. You can make your own operating systems by just having with the basic kernel. You can make your own operating systems and you can make your own device drivers and applications. You can make your own application without any other thing. So basically, you can make your own embedded operating system. So that is very useful. Like if you go into industry right now in embedded, these are like big names: real-time operating system, RTOS, or embedded Linux. You know, so all these things are like big names right now. So if you want to enter into industry, embedded systems, or Internet of Things, then you have to study one of these things: real-time operating system or embedded Linux, or something like that. So then big data, cloud, big data, we already discussed all these characteristics of big data. Then at last, applications of IoT, manufacturing, like predictive maintenance, sensors on machinery, monitoring their performance, and can predict the when maintenance is needed, reducing downtime, preventing costly breakdowns, quality control. IoT sensors can detect defects in real time, ensuring that only high quality products are shipped. Then supply chain optimization, tracking and monitoring of goods in real time to enhance logistics to reduce lead times. So you don't have to that is like anticipating for something to happen. That means you have to waste resources. You don't know when the truck is arriving, so you have to assume that it will arrive at this particular time, and you have to make arrangements for the unloading staff, and they might be working on an hourly basis. So you have to, if the truck arrives like late by 1 hour or 2 hours, then you have to still pay them because they were there. So that type of things can be reduced or eliminated if we have this type of supply chain monitoring systems. Then healthcare systems, smart hospitals, IoT devices that monitor patient vitals, automate inventory management, optimization. So inventory management is a very good thing because for hospitals, inventory management is very critical, because suddenly they have a patient and they need certain medicine, so they don't have it if they're out of stock. That means it is very fatal. It is a fatal situation, might be a fatal situation. So that is very critical. Inventory management is very critical when it comes to hospitals. So that can be automated using Internet of Things. Optimization energy usage in healthcare facilities, medical equipment monitoring status and performance. So that is also very useful and very critical application here, medical equipment monitoring, because like so many critical patients and their life depend on these equipments to work properly. So if they malfunction, then if something is not notified in time, the medical personnel can miss some critical data. Operating correctly and efficiently. So checking that smart buildings, energy efficient IoT devices, control lighting, heat, ventilation, air conditioning, heat, ventilation, and air conditioning systems to optimize energy usage, occupancy monitoring, sensors and track occupancy levels, space utilization, and HVAC settings. Then product examples, specific products like smart thermostat. What we can do, we don't have like a thermostats in India because we don't need them. We need air conditioners. We don't need any heating systems here. If otherwise, other than if you live in the Himalayas or something. So but in foreign countries, in countries where that is north of the equator or south of the equator, they have to use thermostat, cooling, or HVAC systems, heat, ventilation, and air conditioning systems. In winter, it needs to be a heating system. In summertime, it should need to be a cooling system, and it need to keep people warm in general. So these devices learn heating and cooling preferences and adjust settings to optimize energy efficiency, saving you money on utility bills. So this is a so in this case there are two examples, Nest and Ecobee. Nest is a Google system. So this is Nest. It's a smart thermostat. Neat Nest learning thermostat. It's not neat actually. It's Nest. Nest learning thermostat. It learns the temperature you like and builds a schedule around yours. And independent studies show that it saved people on an average of 10% to 12% heating bills and 15% on cooling bills. So in under 2 years, it can pay for itself. So it is a good investment because, like it says, in under 2 years, it can pay for itself. Whatever money you spend on it, on this, like 15,000 or 20,000, whatever, it will pay on itself with the heating and electricity bills. So it can learn and it can act according to that. It's a smart system. Then another smart lighting systems. So Philips, Hue, lifts, all these comes under that. Connected to light bulbs allows you to control brightness, color, scheduling through a smartphone via voice or command. So this type, that one example is Philips Hue. It is not just a bulb like this. It is a whole system. There is another device, and I only have a image of a bulb here, but there is another device, and there is an application, mobile application that you can use. So this is a smart bulb system. It's a smart lighting system. Smart lights, hue, bridge, and smart controls will forever change the way you experience light. Also very energy efficient. Fitness trackers. So we are very familiar with these, like Apple Watches, Fitbit, Garmin, all these companies. So this is a very affordable. Apple Watches will cost so much. So if you don't have that much money, then you can, and still you want to track your health, you can use some affordable, platform like Fitbit. These wearable devices monitor your physical activity, heart rate, sleep patterns, and more, provide the values, insights into your health and fitness. So it provides like you can connect it to your phone, and it will continuously monitor your heart rate, your BP, and you can see how much you're walking, how much you're running, how much you're sitting, how much time you're sitting. All that can be easily monitored using one of these smartwatches or any kind of other kind of wearable devices. Then connected cars. So Tesla is one of the best examples when it comes to connected cars. Tesla has software that enables autopilot mode and self-driving mode in its cars, and advanced driver assistance systems. That is, ADAS helps the drivers by reducing their manual tasks. It helps to improve both safety and convenience. This special IoT feature helps the driver by taking control of the car in mishaps and not idealistic situations. So in a case of any problems, any accidents, anything like that, the IoT system will take charge, and it will assist the driver. So then one of the applications of IoT in Tesla vehicles is over-the-air update system. Normal cars are updated in dealership stores at time as time passes by cars deprecate, and the whole system becomes complex. So this is avoided, like in our Windows system, we have updates I think they're sending updates every day. Some update they're sending every day. So you can say same similar to that. Tesla cars have their own update system. So this is not just some software update that will make your your cluster, like your dashboard, much more smarter or something like that. It will actually affect your engine performance. Not engine, like your it's an electric car, so it will make the performance of the car much more better. That this updates, these updates can even affect that. like last month your car was performing like this, and after an update you can feel that difference. I haven't felt it, but people who have used it said that's the case. So you can do what you want, and the car will update itself. The Tesla S model was the first of its kind that updates itself via on-air updates. So that's it. So that's all the time we have, and we can talk about in a lot of things all day. If there are so many things are there. So thank you guys. I thank you for listening. So we have